Well, hello guys, here Mr. G with another video for the grade 12. This time we're going to be doing question 5 from the mid-year diagnostic exam developed by Professor Rodriguez, and this is about work, energy and power. These questions say two blocks A and B of masses 8 kg and 4 kg respectively are connected by a light inextensible string that passes over a frictionless pulley below or show below. The masses of the pulley and the string may be ignored, and here you have the situation. The system is released from rest while block A is on the floor and B is a distance of 1.5 meter above the ground. State the law of principle of conservation of mechanical energy in words. And this law states that the total mechanical energy in an isolated system remains constant. Important word here is total mechanical energy and isolated system. Those are very important part. Everything is important, but those must be in the definition. Question 5.2. Draw a level free body diagram for block B where it moves downward. So now if we go here, what forces are acting on block B? There are two forces acting on block B. The first one is the weight, which is pointing down, and then the second one is the tension, which is pointing upward. This one is tension. So if we draw the free body diagram for block B, so it is question 5.2 for B, we have the following. If we said this one is the object, there is the weight pointing down and there is tension pointing up, like here. All right, now for A we can do it, however it's not part of the question. Now for A, as it moves, remember it's not going to be right on the ground. You will have the tension pointing up and you will have weight pointing down. That will be for A. Will be very much the same. The only difference is the length of the vectors in this case. In the first case, in B, W will be greater than T, and in the object A, then T will be greater than W. But that is the situation. The question is for block B, so this one is the answer for that specific question. Right? Question 5.3. Classify the force acting on block B into conservative and non-conservative. Give a reason for your answer. Now, there are only two forces acting, as we saw in the free body diagram. All right, there is tension and weight. All right, so we're going to start with weight or gravitational force. So, gravitational force is a conservative force. You have to remember that in actual fact in South Africa is the only conservative force we're working with in this topic. Because the work done in moving an object between 2 points is independent of the path taken. The work done in moving an object is independent on the path taken. The other force acting here is the weight, the tension, and tension is a non-conservative force. Why is tension a non-conservative force? Because the work done in moving an object between 2 points depend on the path taken. So those are the two types of forces we are going to be doing here. Gravitational force, which is a conservative force, and a tension, which is a non-conservative. Those definitions are quite important. They could be asked in the exam. Question 5.4. Calculate the work done by the gravitational force on block B. So for this question, let's see what we have. And we know that the mass of the object is going to be equal to 24 kilograms. That is given to us in the question. We know that the displacement is going to be equal to 1.6 meters. Is also given to us. It is in the picture there. Now, remember we're going to be using the definition of work for this one. Okay, so we need theta, and theta is the angle between the displacement and the force. In this case, the angle is 0 degree. Here is the free body diagram, guys. I'm not going to redraw the free body diagram. The displacement is down, that is for object B. This one is the displacement, and you can see that the angle between the force W and the displacement is 0 degree. Okay. And we are looking for the work done by weight, that is question mark. And when you go to the formulas, guys, this is the formula we are looking for. This is the definition for work. All right, definition for work. So if they ask you to define work, all you have to say is the product of force and displacement and the cosine between the angle of the cosine of the angle between the force and the displacement. That is the formula we are going to be using right now. So the work done by weight is equal to weight multiplied by the displacement multiplied by the cosine of the angle between the force and the displacement. Now we do not have the weight, but it's very simple to calculate the weight. Remember, weight is equal to mass multiplied by acceleration due to gravity. Therefore, we can substitute that one there, right? It's not the need for us to calculate it separated because it's quite simple. So weight or work done by weight is equal to mass, acceleration due to gravity, displacement, cosine of theta. And when you substitute here, which is quite simple, you get which is 24 multiplied by 9,8 multiplied by 1,6 multiplied by cosine of 0 degree. And you will get that the work done by weight is equal to 376,32 joules. That is the weight done by weight, or the work done by weight. And is the answer for this question 5.4. Question 5.5. Use the law of conservation of mechanical energy to calculate the speed of block B when it reaches the flow. So we're working for block B from the moment it was released up until it reaches the flow, and that is to calculate the speed of block B. Now this specific question is a little bit more tricky than it actually looks. Let's go there quickly to the law first of all, and then we'll see what the issue is. They say use the law of conservation of mechanical energy. Remember, we did state that law. It says that the total mechanical energy initial is equal to the total mechanical energy final. Now the thing here in this specific question is that you have two objects moving. This is scalar quantity, so direction is not the problem here, but the system is of two objects moving. So in other words, the total mechanical energy initial is the mechanical energy initial of A plus the mechanical energy initial of B. That is the total mechanical energy initial. And the final mechanical energy total is the mechanical energy final of object A plus the mechanical energy final of object B. That is what we must remember here. Well, what else you're supposed to remember? You need to remember that mechanical energy is kinetic energy plus potential energy, and we are going to substitute this formula there. So what we have here for mechanical energy initial for A, that will be kinetic energy initial A plus potential energy initial A. All this is for A plus same story but for B. Now kinetic energy initial for B plus potential energy initial for B equal to, let's fix this, let's move it to the left. All right, here we are. So now for the final is going to be the same, guys. We have the kinetic energy final for A plus potential energy final for A plus kinetic energy final for B plus a potential energy final for B. And I hope you follow with me. This is something I didn't see in a long time in question papers. It's a very good question to practice. Now, once more, we need to know the formula for kinetic energy and potential energy. So at this point, you need to know that kinetic energy is equal to half mass multiplied by speed to the power 2. And you need to know that potential energy is the product of mass, acceleration due to gravity multiplied by the height. And we're going to substitute these formulas everywhere they need to be substituted in this specific equation on top. Now that is option 1. The second thing is you may do all the calculations separated and then substitute within that long equation there. So it's up to you. We can, you know what, we can try to calculate them all separated just to not get confused. So let's, for instance, start from the left, and let's say kinetic energy initial A is equal to half mass A initial speed A squared. We are calculating that one there. Okay, and we are going to repeat for every one of them. So when you substitute, you get that this half, the mass of A is 8, and the initial speed of A is 0. Therefore, the kinetic energy initial for A is 0. All right. Now, potential energy for A. Potential energy initial for A is equal to mass A, acceleration due to gravity, height A. This is equal to 8, acceleration due to gravity 9,8 multiplied by initial height A. We're talking about initial height A. That one is 0 because it was on the ground. You must go to the picture there. Let me show you. You can see there for A, the initial height is equal to 0. Alright, the initial speed is equal to 0. Alright, the initial speed for for B is equal to 0, and the initial height for B is equal to 1,6 meters. Alright, now what is important to know? The final height for A is going to be equal to 1,6 meters. When this one reach the ground, that one is going to be here at 1,5 meters high, and the final height for B is equal to 0. That is important to know, guys, here in this question. This is a very tricky question. This one is 0 joule. In other words, everything here is going to be 0. Let's go to the next one. Kinetic energy initial B and potential energy initial B. So we're going to do these calculations right now. Guys, I'm doing this one really slow, so I hope you really understand what I'm doing here. So kinetic energy, let's write the symbol we're using. Kinetic energy initial B, we're working with B, is equal to half mass initial speed B squared. Remember that one is 0, so it's half multiplied by 24 multiplied by 0 to the power 2. The initial speed is 0 for both blocks. They were starting from rest, so that one is 0. And the initial potential energy for B is equal to mass multiplied by acceleration due to gravity, we're working with B, multiplied by the initial height B, which is 1,6. So be careful, this one is not 0. Okay, this one is going to be 24 multiplied by 9,8. Everything here is positive, no directions needed because these are scalar quantities. This one is 1,6, and then the answer is going to be, and the answer here is 376,32 joules. All right, so we do have that value there. Let's go to the final. So let's do all the calculation for the kinetic and potential energy final of A. So what we have here, kinetic energy final A is equal to half mass A final velocity or speed A to the power 2. Now this final velocity A is going to be the same as the velocity final for B. Okay, that is an important detail here to know, and it's unknown, we don't have it. So we have this one is equal to half mass A is equal to 8 multiplied by the final speed square. I'm not going to write the 8 anymore because it's the final for both of them. So this one is equal to 4 multiplied by final speed square. We stop there because we don't have those values right there. So let's go to the final potential energy for A, and that one will be equal to mass multiplied by acceleration due to gravity multiplied by the final height of object A. Remember, I show you the picture there. The final height for A is 1,6. So we come here and we substitute. This one is 8 multiplied by 9,8 multiplied by the height, which is 1,6. All right, and we get that this one is 125,44 joules. That is the other answer we have here. So now we have only to answer the final, or to calculate the final kinetic and potential energy for B. So now we're going to do these calculations here, kinetic and potential energy final for B. So the kinetic energy final for B is equal to half mass B final speed B squared. Remember I said that the final speed for B is the same as the final speed for A. So when you substitute here, you get that this half mass is 24 multiplied by Vf square. I'm going to write just Vf square, and this one is going to be equal to 12 Vf square. All right, we have to stop there because we have two unknown. We have an unknown there. Let's go to potential energy final for B. Potential energy final B is equal to mass B, acceleration due to gravity, final height, and if you substitute this 24 multiplied by 9,8 multiplied by the height, which is going to be 0 because it's when it's going to be at the ground. So this one for B is going to be equal to 0 joules. Now guys, we have all the calculation, we have all the numbers we need to substitute in here. So let's now substitute everything we have. We said that all this one is going to be equal to 0. 0 plus kinetic energy initial of B, kinetic energy initial of B is 0. So it's equal to 0 plus potential energy initial B is 376,32. 376,30. This is a 732. This is going to be plus kinetic energy final A. So for final A we have 4Vf square. It's going to be here equal to 4Vf square plus potential energy final A is going to be 125,44 plus kinetic energy final B is 12V Vf square plus 0, which is the final then. So guys, and the rest is simple mathematics here. Okay, so we're going to group like terms. In this case we have the Vf square and Vf square, and we have the 125 and the 376. So we are going to rearrange this one so we can answer the question real fast. But it's quite simple now. It's 376,32 minus 125,44. This is equal to 4 V final square plus 12 V final square. When you calculate, you will get that is 250,88 equal to 16 Vf square, guys. So this one is 250,88 divided by 16, and then the square root of all that is equal to final velocity. So the final velocity is going to be equal to 3,56 meters per second. That is the final speed, of the speed with which block B reaches the ground, which is the same speed of block A at that specific time. You know, this one is a little bit of challenging question. It's a very good question, guys. Okay, sorry, here is not 56, is 96. Let's fix this number here. Just looking at my calculator. You know, sometimes I do all these calculations as I'm making the video. So this one is 3,96 meters per second. I look wrong at the calculator. Question 5.6, state the work energy theorem in words. And guys, This one is here in the formula. This formula here is the work energy theorem in word. Work energy theorem. That is the work energy theorem in symbol. You just have to write it in word. So let's write the formula here. Net work is equal to change in kinetic energy, and that is all you have to say, but now in words. So all you have to say is that the net work done on an object is equal to the change in kinetic energy of that object. That is the work energy theorem. And the final question say, use the work energy theorem to calculate the maximum height reached by block A. And this one is also a very important, very tricky question here, guys. Note the following. When the object B reaches the ground, object B, A is going to be at 1,6 meters above the ground. That is for sure 1,6 meters. But the problem is that object, because of inertia, doesn't stop there. So it continues moving up. It continues moving up due to inertia. That is moving up due to inertia. This is a very good, very tricky question. So as from there, the tension is not going to be acting on the block anymore. B reaches the ground, but A, due to inertia, continues moving a little bit more as from the 1,6 meters. So it continues moving up at a certain height. That is what we are looking for. At that specific point there, the only force acting is going to be weight, because the rope is not going to be acting anymore on the object. So only weight will be acting on that specific object there. So let's solve this question real fast. Now in this question 5.7, they said use the work energy theorem. So we must start from there, using the work energy theorem for that specific block, which is block A. Now the only force acting on the block at that point is the weight. Okay? Gravitational force. So in other words, net work will be the work done by gravitational force. So here we have work done by, I'm going to write gravitational force is equal to half mass final speed square minus half mass initial speed square. Now the initial speed here is the one which with the block leave that 1,6. So this initial speed is the one we did calculate previously, the 3, this initial speed here is 3,96 meters per second. That is important to note there. And the final speed is going to be equal to 0. Alright, so saying that, guys, we can calculate all this. It's not difficult anymore. So we have here that is mass multiplied by acceleration due to gravity, multiplied by displacement, multiplied by cosine of theta. In this case is 180 degrees. Remember, the object is moving up, and then the gravitational force is pointing down, so the angle is 180 degrees, equal to half mass multiplied by a final speed square minus half mass initial speed square. And all we have to do is to substitute here. Mass is 8 here, 9,8. The displacement is what we are looking for. We don't know that one. Cos of 180 degrees is equal to half mass is 8. The final velocity is 0, speed square, minus half mass, which is 8. Let's substitute the number. 8 multiplied by the initial speed, which is 3,96 square. Guys, here is some calculation we have to do right now. So here we have that is minus 78,4 delta x equal to 0 minus 62.73. Okay, now we rearrange this one here, and we are going to get the displacement, which is going to be equal to 0.8 meters. Now I want you to be careful. This is not the final answer. They say maximum height reached by block A. That we calculate is just from here up until a certain point. So the maximum height will be the addition of the 1,6 plus the answer we just get here. So we're going to go there all the way down. This is all the answers for the other questions we did answer already. So here we are. So the maximum height, H maximum, is equal to 1,6 plus 0,8. That will be the final answer, and therefore the maximum height is going to be equal to 2,4 meters. This is the maximum height reached by the block from the beginning up until the end of motion. Okay, so that is the maximum height reached by that block. It's a very, very good question, guys. I hope it helped. So if it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.